Hello, my name is André Neves. I'm a junior engineer at Unicage Europe, and I am here to present the work that I developed for the DISTEMIST challenge, which was a named entity recognition system using only Bash and Unicage tools. The DISTEMIST challenge was composed by two distinct tasks: the entities subtrack, that consisted in automatically finding disease mentions in published clinical cases, and the linking subtract, that consisted in assigning to each mention a respective SNOMED CT term. To tackle this challenge, the main objective consisted in developing the first named entity recognition pipeline using Unicage technology and applied to the biomedical and multilingual domains. This pipeline would consist in a minimalist solution capable of being executed in a simple laptop using just Bash and Unicage tools. This way, a dictionary lookup approach was chosen to fulfill these requirements, although the developed solution was only able to be submitted for the DISTEMIST entities subtrack. So what is Unicage? Unicage consists in a shell scripting development methodology with focus on big data processing. Part of this methodology is a set of command line tools that are written in the C programming language and that have been geared towards performance, leveraging the operating system's memory and resource management capabilities to deliver high-speed processing. The variety of commands is also able to cover the gaps that are present in the toolbox of built-in OS utilities, thus providing the user with additional tools for a plethora of operations. Also, data processing steps are connected through pipes, thus potentiating a better usage of the system's resources. Finally, Unicage follows the Unix philosophy that emphasizes in building simple, short, clear, modular, and extensible code and can be easily maintained and repurposed. Unicage also works as a data engineering framework, capable of integrating data from different sources and formats and standardize it, so that the manipulation and transformation of this data can be done with increased efficiency before outputting it into the respective format or platform. Taking everything that has been said until now, for the DISTEMIST challenge, I have developed Unicage-NER, a minimalist dictionary lookup method that only requires two input files: the corpus, which is composed by the clinical cases test set provided by the challenge organization, and a lexicon file, which comprises a list of thousands of disease names, synonyms, and related terms that were extracted from several ontologies and datasets. Unicage-NER is divided into three distinct sections: Corpus Normalization, NER, and Entity Cleaning. The Corpus Normalization section consists in taking the input corpus, which is a text file, and convert it into a tokenized version of one word per line. This is easily achieved using a combination of Unicage commands that split the text into one word per line. Then, the position of each word is calculated through a small script in awk, and it is applied through a Unicage command that offers an optimized performance. The NER section receives the previous file as input, as well as the lexicon file, and it works as follows. Considering L as the max length of an entity in the lexicon, a total of L iterations are executed. In each iteration, combinations of words from 1 to L are made. These combinations of words are then matched with the entities from the lexicon. For this, a Unicage command called join will be crucial. Finally, in each k iteration after the first n words of each clinical case are removed, where n will be equal to k minus 1. Let's look at an example. In this example, the largest entity in the lexicon has 3 words. Therefore, our value of L will be equal to 3. We are also in the first step of the cycle, so the number of words per line will be 1, and our k iteration is also 1. As we can see, the join command detects 3 entities from the text that are present in the lexicon: dopamine, Parkinson, and brain. These 3 entities will be then stored inside the file. The cycle passes to the next step, and combinations of 2 words per line are made using Unicage commands. Now, the entity Parkinson disease is identified by join. And then, combinations of 3 words are made, and as we can see, no new entity is found. We now increase the value of k to 2. Therefore, we have to remove the first word of each clinical case. In this example, it is the word dopamine. The number of words per line will be equal to 1 again, and join detects the entities brain and Parkinson. Now, in the combination of 2 words per line, we are able to detect 2 entities that we didn't detect before, which are cognitive deficit and motor deficiency. We pass again for the combination of 3 words per line, and again, no entity is found. And now, the value of k is increased to 3, so we have to remove the second word of each clinical case, which in this example is the word loss. The join command then identifies the entities, and this process will repeat for 2 more times before it ends. The final section is the entity cleaning, which uses a combination of Unicage and Bash commands to remove all duplicate and overlapping entities before saving the results in the format required by the challenge organization. Regarding the lexicons used in the competitions, since there was a limit of 5 submissions, 5 variations of the lexicon were made. These variations comprise modifications, such as removing special characters and punctuations, removing entities with 3 words or less, stemming using a specific algorithm, and using additional entities retrieved from other datasets. As to the results, they were not optimal, with a difference of more than 0.40 points from the baseline system. However, Unicage-NER was able to surpass another system in the macro-precision measure and in the micro F1 scores. The system was based on a Levenstein lookup approach. In conclusion, although the results weren't great, I was able to develop the first NER pipeline in a simple and minimalist way for the biomedical and multilingual domains using Unicage technology. However, as the competition results showed, these dictionary methods alone are not optimal for these types of competition, which require the usage of more complex algorithms. Nevertheless, I shall try to improve the results achieved in this competition and, as a future step, try and complement other natural language processing pipelines with Unicage commands and methodology in order to try and improve their results and performance. Thank you all for watching. If you have any questions regarding this work, please contact me through the email that you can see on screen. Additionally, if you want to know more about Unicage, feel free to visit our website and book a meeting with us. Thanks again, and until the next time.